Okay, we're going to look again today at quadratic equations, but we're going to look specifically at that quadratic formula that we talked about yesterday, where we have negative b plus or minus the square root of b squared minus 4ac over 2a. This in the center is called the discriminant. So we're going to look at that discriminant to make some determinations about our problems. Okay, we're going to look at quadratic equations, and you're going to determine what the best way of solving the quadratic equation is. We're going to decide if we need to take the square root property, if we need to factor a problem, or if we need to use the quadratic formula. Completing the square usually isn't used because you can use the other techniques and they're easier, they have less steps. If you like using completing the square, you're free to do so though. Okay, when we're trying to solve quadratic equations, the first thing we want to do is write it in the form of ax squared plus bx plus c. If b equals 0, like we had some problems in 12.5, we're going to actually isolate the x squared and apply the square root property. So that means we're going to do some type of manipulation so that we can apply the square root property. If the polynomials factor easily, then we're going to factor the equation. Or our third choice is to use a quadratic formula. That's for all the problems that do not factor easily or do not have a perfect square. Okay, let's look at the discriminant. It tells us some information. It's what's inside the radicand, the b squared minus 4ac. And when you look at the discriminant, it can tell you how many solutions there are for a problem. If it equals something greater than 0 and it's a perfect square, then there's going to be 2 rational answers. If it's greater than 0 but it's not a perfect square, then there are going to be 2 irrational answers. That means there's going to be a radical left in the answer. If d equals 0, then there's going to be 1 rational answer. If d is less than 0, there are no real solutions because that would mean that you're taking the square root of a negative number. Let's look at this example. Okay, we have this problem here. Let's see what we think might be the easiest. 7 doesn't factor easily. There isn't a perfect square, so let's put this into the quadratic formula. And we see that the discriminant is 53, so there are 2 irrational solutions. In this one, we can see if we put it all together on one side of the equal sign, our discriminant, we have our A, B, and C. Our discriminant is going to equal 625. So that means there are 2 rational solutions. It's greater than 0 and it's a perfect square. This one, when we put it all in one quadratic equation, we have A is 3, B is 5, and C is 9. So when we look at our discriminant, it equals negative 83. If D is less than 0, in other words, if it's a negative sign, then there is no real solution. Okay, so if the solutions are x equals 5 and x equals negative 7, then knowing what we know about the discriminant, those are 2 rational answers. So we know that we're going to get this. If we have x could be 2 over 3 or x could be negative fourth, we're going to multiply to clear fractions. So we multiply the top and bottom by the same number to make it equal 1, or in the first case 2. And we're going to set them both equal to 0. And we come up with a new, this is our equation that goes with those two x answers. Here's another example. This time we're going to be dealing with a triangle. X is going to be our hypotenuse. X minus 3 is one leg. X minus 5 is another leg. We know that if we square A and B and add them together, then it's going to equal x squared. So we have this. And as we further solve that, we actually go x minus 5 times x minus 5, which is this part right here, when you split it up and FOIL it, and then x minus 3 and x minus 3 is this. And when we combine like terms, we end up with this problem here, x squared minus 16x plus 34. And our discriminant then is 120. That is greater than 0, but it's not a perfect square. So that means the solutions will be irrational. There will be two solutions, but they'll be irrational, meaning they're going to have a radical in the answer. So let's look and see how that works out. Let's go ahead. We can put this in our quadratic equation. And we've already figured our discriminant, so we know the inside of the radical is 120. And negative 16 was our b, and 2, we have 2 times a, which is 1, so we end up with a 2. And if we go ahead and simplify our radical, we end up with this. We can do some reducing though, because this is a fraction and everything is made of even numbers. We end up with 8 plus or minus the square root of 30. So if we look at 8 plus or minus the square root of 30 in terms of a triangle, we know that the hypotenuse has to be longer than the sides. And if we remember, our sides were something like x plus 5 and x plus 3 or something like that. And this was x. No, this was minus, sorry. Those were minuses. So if we look at our plus or minus sign here, that means it's 8 plus square root of 30 or 8 minus the square root of 30. If we put these in our calculators to get actual distances, we get 13.48 or 2.52. Now, if we took x and subtracted 5 or took x and subtracted 3, if x was only 2 something, that would give us a negative number for our distances, and we can't have a negative number for our distance. So 13.48 is going to be our reasonable answer. So that'll make leg 1 be 8.48 and leg 2 be 10.48. And our hypotenuse is still longer than both of those, so we know it seems like it should be a reasonable answer. And here's your homework for the day.